Thank you, Ajit. Really appreciate it. Excited to be here to talk about 6G and beyond. And I know that there's probably a number of people that eyes find their way into the back of their head when people start talking about 6G, when we still have quite a bit to talk about with 5G. But as every G has one impact to the next, and there's no waiting around, right? And coming up with what's going to be following 5G, the discussions for 6G are already underway. There are a number of regions that have kicked off efforts to try to get in front of figuring out what 6G is going to be, what it's going to be used for. Certainly there's one in the United States led by ATIS called the Next G Alliance, which I know a number of the organizations that have been participating in the summit are heavy participants, including MITRE. And so we've brought together a group of experts today to really, kick the tires, around 6G and what ultimately that might mean. And so we'll start off with each of the panelists giving a short, 30-second or so introduction for themselves and what their roles are, and then we'll get right into talking about 6G. So with that, let's see. Jason, would you like to go first?
Hey everybody, I'm Jason Schnellbacher. I'm in the Advanced and Emerging Technologies team at T-Mobile. We're kind of like an R&D group that focused on using the network. So I'm not in standards, but I have a lot of experience using the network and kind of share some insights on what that might be needed for the 6G era.
Awesome, thank you. Prasanth, you want to go next?
Sure. Hello, my name is Prasanth Ananth. I'm from Nokia in Murray Hill, New Jersey, and I lead the research and development on autonomous indoor drones. And these indoor drones are connected over cellular networks, 4G and 5G today, 6G in the future. And in addition, as part of the Open Generation Consortium, I'm leading the testbeds working group.
Thank you. Walid, you want to go next?
Yes, so my name is Walid Saad. I'm a professor of ECE at Virginia Tech, and I'm also leading the wireless research for our new innovation campus here in DC. My work is really at the intersection of wireless and AI and the synergies between the two, with applications across drones, XR, metaverse, and whatnot.
Awesome. And then Venki, would you mind batting cleanup for us, please?
Yeah, Venki Ramaswamy, Chief Technologist for Next G at MITRE Labs. I'm responsible for all the R&D activities in 6G. And my focus recently has been on the aspects of 5G and 6G that will make it very attractive for mission-critical systems. And the hope is that that will accelerate the adoption of these new technologies by the US government. Thank you.
Thank you, everybody. Thank you, Venki. So to get right into it, I think we need to table set a little bit, before we start talking about 6G, to talk about, there's this kind of promise, right, that the current G is supposed to fulfill all the promises that the prior G didn't. And we're still working on 5G, and so I think the first thing we need to take a look at is what are some of the challenges or shortcomings with 5G that might be delaying kind of a broader US or industrial adoption, right, in the larger marketplace, right, to really get after some of that new revenue generation that I know everybody's hunting for. Jason, you want to take a first crack?
Yeah, so I focus on using our 5G network quite a bit, and most of the network today is release 15. With the devices that are available, we're starting to see some new release 16 devices that open up a little bit more capability. But one thing I've seen a trend is a need for more uplink. That there's a lot of 5G use cases that need uplink, but a lot of the spectrum that's available in the mid-band that have high capacity is TDD spectrum, which is has a fixed frame configuration, usually with the majority of that being downlink. So we kind of have a disconnect. And so, I think that's one of the things we could talk a little bit more about on the panel today is techniques and methods to get more uplink and to more dynamically use that TDD spectrum for more uplink specifically. But that's an area that I think is of interest. But there's a lot of stuff in 5G we haven't even implemented yet, right? So some of the carriers are just now getting into network slicing and can do that maybe with an individual device and put it on one slice, but being able to do that dynamically with multiple types of traffic on a given device to go on different slices, that's all still new frontier, right? So I think there's still a lot of things that can be done in 5G that we just haven't gotten to yet as an industry. But there are some things that we're going to need to probably look to 6G or these future releases to help solve. Another challenge that I wrestle with sometimes, I do some of the drone work with T-Mobile and our various partners, is handover latencies. So if you're flying across a sector and you go from one sector to another sector, you can see spikes in latency sometimes, and being able to maintain always on low latency connectivity, even persistent of a handover, is another thing that I think could benefit from some work for all the smart folks working on this next generation.
Right, and I think that speaks to, a lot of the 5G deployments today are focused on enhanced mobile broadband, right, and not as much around the ultra reliable, low latency, massive machine type comm space. Right. And I think that solutions like what you're talking about with drones, right, are really need that URLLC capability. But there's this chicken and the egg problem of, well, we could start to see the manufacturers start to build for that. But what's the revenue? What's the new revenue? Where's the money going to come from that's going to incent the creation of that marketplace, right? Anybody like to follow, Jason?
I can maybe add a little. Yeah, I can maybe add a little bit based on our experience in the testbeds working group. Certainly, we see that 5G it's typically designed with terrestrial devices in mind. Drones, especially outdoor drones, on the other hand, are an altogether different challenge. And these are the kinds of challenges we are evaluating in the testbeds working group. So if you have a drone flying in the air, this sees not only several base stations, but also the uplink signal from the drone is visible to several users as well, and several base stations as well. And that causes uplink interference. And these are the kinds of challenges we are evaluating as part of the testbeds working group. How do we address these challenges?
Thank you, Walid. I think you had a thought as well.
Yeah, sure. I wanted to kind of follow up also on the reliability aspect. I think that's one of the roadblocks hitting 5G in some sense, in the sense that we still don't know if we can achieve what targets of reliability we wanted before. And that's in the sense of having continuous low latency, right? I mean, we can simplify it and say, can we have low latency, like for a drone or any other application, continuously around their environment, especially if they're mobile? And I think another angle where 5G is still kind of tweaking around is guaranteeing high mobility, high speed together with the high frequency. So this high triple H, if you want, aspect, we can do high. I think we can do really well with mid-band or sub-6 gigahertz. But when it comes to millimeter wave or higher frequencies and mobility, this remains a big challenge.
Thank you for that, Walid. Venki, any parting thoughts before we move on to the next question?
Quickly, perspective from our U.S. government. Use cases that we are interested in, such as the national security use cases and public safety use cases, they require resiliency guarantees, right? Without that, it's not going to happen. And unfortunately, there is no document, no minimum specification that is specified for 5G that calls out resiliency as a performance guarantee. There is something called as reliability, but that's a very weak concept, much weaker than the resiliency concept, and it is very specific to the link itself, not the network as a whole. So without resiliency guarantees, there is no way that 5G or 6G system will be adopted by this mission critical system. So what we need to do is we need to have such a requirement in a document like IMT 2030. That specify the minimum requirement for the next technologies. So that's one aspect. The second is that 6G technologies that should have ability to seamlessly integrate with other systems, because there are systems that are already deployed in the network that are for very specific purposes that are not going to go away anytime soon. So if 5G or 6G needs to be adopted, it has to work seamlessly with existing systems. Some of these systems could be commercial, could be DoD, could be proprietary, but there has to be ability by which they could easily integrate with other systems. The third thing that I would say is that simplicity is a very important factor. When I talk to folks that are actually deploying wireless networks, they often lean towards Wi-Fi. even though they know that Wi-Fi is not going to provide the kind of performance guarantees that you can get from cellular. They go with Wi-Fi because the deployment itself, deployment, operations, management, everything is much, much more easier when it comes to Wi-Fi. So, unless we focus on these three aspects for our next generation technologies, it's not going to be attractive from a mission critical perspective. Over.
Right, and so a lot of what what we've just talked about is some of the things that were promised or sitting inside the IMT 2020, that beautiful triangle that was put together around ENBB, URLOC, and MMTC, and those enablers trying to get after use cases sitting on the interior of that triangle, right, and really get an understanding of what those use cases are. And so if we lack some of the performance enablers that would get after what Jason was talking about, which is solving handover issues while doing drone flying, from a transition from one sector to the next, right? Then, if we still need to solve those problems from a 5G perspective, then it begs the question, well, what are some of the requirements around 6G, right, that would go above and beyond where we're even seeing under promise from 5G? And so, what are some of those new use cases and requirements? But, Venki, to start with you, the question that I think that everybody always asks, right, when 6G comes up as a topic is, why are we talking about 6G, given all the challenges we just talked about still remaining with 5G?
So when we are talking about 6G, we are talking about 2030 timeframe, right? So there will be some applications that we can expect, but there will also be applications that we don't have any idea of. One of the things that is mainly talked about is this idea of metaverse being the main use case for 6G, right? And in the previous panel, Amitabh talked about the requirements of metaverse, right? And there are also documents like, from GSMA that talks about the bandwidth, the data rate requirements. I've seen numbers like, 700 Mbps per user, latencies of less than 5 milliseconds. So if you want to achieve those kind of requirements, current 5G networks, I mean, you can see the expected performance from the IMT 2030 document. It's not going to provide. So we need something that is better than what we have today, just in terms of providing data rate, latency, jitter, and so on. So that's one aspect. So to satisfy something that we expect in 2030, I think we need better technology than what we have today. The second aspect is that, when we designed 5G, we were living in a completely different world, so to speak. Things have changed a lot. Our societal, our environmental goals, our priorities have changed a lot, right? So we have, in 2015, there was a UN document on sustainability goals. So there were things that were set as priorities for the next technologies. So 5G was when it was designed, we didn't have those goals in mind. Now we have those goals, and we need to have next generation technologies like 6G target those goals. So green aspects of communication, energy aspects of communication, sustainability, all those things need to be there. So the next gen technologies should have not only the key performance indicators that we have seen before, such as data rate, but also these additional aspects such as sustainability, cost, energy efficiency, and so on. So we need a completely different approach that will include all these environmental, societal, and governance aspect introduced into the technology.
Thank you, Venki. And now, Prasanth, I know that you've also been thinking about, where some of the use cases and requirements might need to go from a 6G perspective. Can you add to what Venki just said, please?
Sure. I'll maybe start with something that's first close to my heart, which is robots and drones. And there, certainly when you want to localize robots outside, GPS is possible. But when you're moving indoors, today we use cameras and LiDAR and different sensors for localization of these robots. And this is in addition to any connectivity that need. Now with 6G, the promise that you can do both communication and sensing jointly, I think that would be a game changer. So I think that would be a real game changer for the robotics industry. that when you can do both, and you can now eliminate, hopefully eliminate cameras and LiDAR completely from these robots and drones. And the second thing that I also see is, given the large bandwidth and the low latency available, you can offload a lot of these processing to edge clouds for edge processing. And that basically means you can reduce the power consumption, reduce the size, and have longer flight times, longer times of operations for these robots and drones. Those are all benefits that I see that 6G can bring to robots. But when I say robots, this also generalizes, I think, to wearable devices. If you're thinking of XR glasses and so on, which you want to be small, low power consuming, all these benefits also apply to them. And Venki mentioned metaverse, and I would be remiss if I don't talk a little bit about that. So metaverse is more of a broader concept than a use case. And in Nokia, the way we think about it is not just as a virtual, purely virtual metaverse, but rather a fusion of digital and physical world together. So, and this would be where the digital world is a replica of your physical world, or a digital twin in some sense, and you're able to also interact with this digital world via the human, as a human. So you're able to make manipulations in the digital world, and that gets reflected in the physical world, and so on. So there are two parts to this. One is the digital twinning part, and there's the human augmentation part. So those are the two things that we talk about in the metaverse. And when you think about such a construct, then you want to be able to construct these digital twins from the physical world, which basically means massive amounts of bandwidth being exchanged. And when you're also talking about interactions with this between the virtual world, between the digital world and the physical world, that means you want low latency, reliability, and so on. So when you go to metaverse, 6G would be a key concept there.
Thank you for that. And I'm definitely going to be pulling on the metaverse thread, I think, throughout this panel, because I certainly have lots of questions myself for what that actually means. Walid, Jason, any thoughts on what you think 6G's use cases and requirements are going to need?
Sure. I mean, I can dovetail quickly on what Prasanth has said on the metaverse. So there's this twinning aspect of it, and there's the virtual aspect of it. And one is kind of just present there, and the other has to be continuously reflecting the physical world. So you can start thinking about there's different levels of synchronizations happening there, right? So you have a portion that has to mimic the physical world near real time, and that's extremely low latency. Another that can wait a little bit, but it's still interacting with it. And I think that brings in an aspect a little bit different than 5G, where we talked about eMBB, high bandwidth, and low latency reliability. Here you actually have a merger of the two. You have high bandwidths, and you need to maintain low latency and also reliability to maintain synchronization. This is a massive challenge, because we cannot, I mean, we can do it with short packets now, but when it comes to very high rate, I think that's really a big thing that comes into the picture there. And I think this theme of sustainability that Venki mentioned is something that can be actually generalized across 6G, in the sense of doing less with more. So can we do, doing more with less? So can we actually leverage local computing in order to communicate less, right? Can we actually use less energy across our devices in order to convey more information? So I think that's something that will cut across the 6G KPIs in some sense.
Thank you, Walid. Jason, any thoughts?
Yeah, just briefly, the concept that Walid mentioned was about local computing. You know, I think that supporting some of the metaverse things sound a little bit aspirational on how are we actually going to do these things, and makes me think that part of the 6G needs to look at architectural options that do include local computing and being able to render on devices or nearby compute. You know, I think that's probably going to be an important aspect of the future for me.
Right, and at least for me, like whenever I hear metaverse, right, I immediately think about Neil Stephenson's Snow Crash, right, where I think, you know, some of these terms were even brought up for the first time, right, and the concept of a metaverse inside of that book is what I think extensively we would call augmented reality, right? It's an overlay, right, over everything that we see from a visual perspective with direct data input. You know, but it's not immersive, you know, virtual reality, right? It's augmenting our existing reality, or is it going to be kind of like the Ready Player One version of a metaverse, right? Which is immersive virtual reality, but virtual reality in a way that it still has a physical impact, right, with the ability for motion, or whether that's actually physically accomplished, through the unit treadmills or whatever other mechanism, right? So I'm thinking it from an end user's perspective with metaverse, and then thinking backwards for, okay, what technology actually needs to be developed, right, to actually get after a use case like that. And so maybe what we can do is we can start to transition into looking more specifically, what are some of those technologies, right? I mean, Jason, you talked about some of these things being aspirational. What are some of the things that we're going to need, that 5G is specifically not delivering from an enabler perspective, that we would need for 6G for some of these use cases. Let's see. Venki, do you want to go first?
Sure. So if you remember, I talked about three things with respect to challenges, right? So one was resiliency. Second one was seamless integration. And the third one was reducing complexity. So let's start with the first one, resiliency, right? So there are certain characteristics that resilient systems usually exhibit. One is they have this ability to anticipate any threats and things like that. Second one is they have enormous amount of situational awareness. And third one is that they are able to completely adapt. So with respect to awareness, right, to improve awareness, we need to have all sorts of sensing capabilities. So ideas that somebody before talked about joint sensing and communication, right? So that would be an important aspect. How do we improve anticipation, right? So anticipation we could do by adding a knowledge plane or an intelligence plane to already existing control plane, data plane, and management plane. And awareness and anticipation is just not enough, right? Because you could be aware of things, you could be anticipating what is going to come next, but if you're not reacting to that, right, it's not going to really help. So how do you react? Having a very programmable network. So programmability, not only in the control plane, but also in the data plane, where you could actually change the packet processing pipeline dynamically. So I think these three ideas, which I call as AAA, awareness, anticipation, and adaptability, are key aspects that we need to include in the next gen technologies. The second one is the seamless integration, right? So seamless integration with other technology, other networks, such as the aerial, space, maritime networks, and so on. And in 5G, we already have elementary versions of how to do this using things like N3IWF, non-3GPP interworking functions. But it's very elementary, as I said before. We need to have a very seamless integration with all these networks. And that's also going to provide the ubiquitous coverage that we are hoping to get in 6G, right? 100% coverage. So in order to get to that level, we need to have all these different technologies seamlessly integrated. The third one is complexity, right? How do we reduce complexity? And there are ways by which we can do this. One is what a lot of people talk about is a zero-touch automation. How do we actually do this without really changing any configurations and things like that? And the technologies that are going to help with this is called as the intent-based networking. So you provide the intent, the network operator provides the intent, and that intent is automatically translated to the QoS requirements, that is automatically translated to the parameters and configurations of each of the network elements. So all these different aspects need to be there in the sixth gen technologies, and by bringing them together, we would have something that is more reliable, that can seamlessly integrate with other technologies, and that is also simple to operate and has simple management and operational activities.
Thank you, Venki. Now, Jason, I know you've also been thinking about, what some of those technology enablers that need to exist within 6G, and given that your hands are on your network now, right, to try to get after, what you want to accomplish in 5G, what are some of those 6G enablers you're hunting for?
Yeah, the big one for me is more uplink, as I was saying before. The and the dynamic utilization of the spectrum in the uplink direction, and deterministic kind of 3GPP network, right? Everything's got to be timed, time synchronized, and so, it's not really possible to have more uplink here and there that the sites get out of sync. And so, for me, I think that's really important. Those are a lot of the examples, the things that you can't do in 4G, right? That you can only really do in 5G, and if you really want to do it in a bigger way, you're going to need some advancements in the 6G era. But if you look at some of those metaverse examples we were talking about earlier as well, if you think about the bandwidth, that's fine for a couple users who get on and off the network. But if they're on there for extended periods of time, simultaneous and concurrent, right? That's a lot of capacity. That's what I was saying. Some of these architectural impacts, I think, are going to be important, because I don't know how the network's going to sustain that. You're going to need more spectrum. Where does that come from? Can you even get it in a building, right? That's getting signals into the building where people are is not easy. And the higher you go in the spectrum, the more challenging that becomes. So I feel like being able to address those higher concurrent, simultaneous high bit rates with the reliability and the low latency that was discussed, but also more uplink would all be important.
Thank you, Jason. Walid, any thoughts from your perspective?
Yeah, I think one key technology is actually the use of AI, right? So what is the role that it will play there? I think there's actually, we can split it into two categories. The first one is more along the lines of what we're starting to call AI native networks. It's the idea that the system will be designed ground up with AI. And why is that? There will be three possible use cases. One is most of these end-to-end communication scenarios that we're gonna deal with in 6G, like the metaverse, don't have rigorous models. I mean, or even if we have models, they're limited in their expressionability in some sense, right? If you have local computing and an encoder and it becomes complex. So that's AI plays a key role. Second, you will have complex optimization problems, right? Now you have resource management at scale, and so solving those data-driven algorithms is much more effective. Third is this whole joint sensing and communication, right? I need to learn the environment, get situational awareness, and feed it into communication. AI will play a key role there, right? So it can actually learn from the data and make things work. The second group is the flip of the coin. Many of the applications we discussed, including the metaverse, groups of robots, collaborative autonomy, they actually use AI that needs to kind of circulate over the network, right? Example would be federated learning, right? A group of robots need to send their weights, their neural network, and they need to make sure that their machine learning is accurate. And that is affected by the wireless, right? So how can 6G and 5G in some sense also support some of these applications? I guess these are like, the main view on AI and AI native networks as they apply to 6G.
Thank you, Walid. And then Prasanth, for you, I know we have a question from the audience, suggesting that there needs to be a new type of peer-to-peer protocol, right, going from 5G to 6G to enable some of the things that we've been talking about. What are your thoughts on that?
Yeah, I can say a little bit about what we're doing today. So certainly robots need to communicate peer-to-peer. You can use device-to-device communications, which some of the standards allow. But beyond that, today you can certainly communicate via the base station. So although it is peer-to-peer, it would go via the base station, and we already do that today over LTE and 5G. And that works okay, except for the points that Jason mentioned. So things like being able to hand over quickly, having higher uplink. And typically that's an issue for robots, especially because when current networks are designed, they're typically designed with higher bandwidth on the downlink versus the uplink. Whereas with robots and drones, you actually need the inverse. You want higher uplink. The downlink is actually much smaller. So those are the challenges that we face. But typically, the peer-to-peer connections can be handled even via the network.
Thank you for that. Now, I know we have another question in the audience, and I'll field a little bit of this one, right, which is talking about the convergence of terminology and definitions, right, even from a 5G perspective, let alone 6G. I'll confess that within the ATIS NextG Alliance, I chair the Spectrum Working Group. And one of the first things that we did was we put together a deliverable that was, terminology definitions in and around the spectrum space. It took months to actually get to common terminology for how we could refer to spectrum. And you'd think, right, that given the requirement, right, for commercial mobile network operations, the need for spectrum, that we kind of be beyond, you know, having to figure out how we refer to different spectrum bands, but we're not actually. And so even from a regional perspective, looking in North America, it's a challenge to get to common terminology around something that you'd think would be simple like spectrum, let alone do it from a global perspective. At least from a 3GPP perspective, one thing I can say is that, you know, when I participated there, 3GPP does a wildly good job of defining terminology, right? There's a set of key documents that define the terms that are sitting within 5G. Some of the terms we've been throwing around on this panel, though, even, you know, to pick on one, Venki, from you, the concept of reliability, right? Where do you measure reliability, right? What are all the different aspects of reliability? You know, what are those KPIs? And so those are things, right, that those types of words aren't well defined in the lexicon of 3GPP. Those are things that are typically defined from an implementation perspective beyond the standards themselves. And so that gets into more difficult terrain, right, to expect, at least up front when we're just starting to talk about 6G, that we have kind of a common vernacular there. But so that's just kind of my 2 cents on terminology. Didn't know if anybody else wanted to chime in on that before we get to some of, you know, the challenging topics that we set for ourselves for kind of closing out the panel.
I can maybe add one more thing. So certainly within the testbeds working group, we have a community from the communication side and also a community from the aviation side. And when we compare the terminology across the two communities, it's completely different. So that already when we talk about terminology, I think having this consistent terminology across different communities is also an issue.
Yep, very much so. Now, challenging topics. So one of the challenging topics we set for ourselves, we've talked about it a few times, and I just mentioned it, which is spectrum. And, you know, I think we heard it in the last panel, right, that when it comes to some of the high data rates, right, that we've been talking about, you know, on this panel, whether it comes to metaverse or drones or what have you, that ultimately will require millimeter wave because there's a lack of sub-6 spectrum that would actually enable some of these types of use cases. I guess I believe that, you know, we're starting to get to a point where you know, the ability to clear and license spectrum, right, for the next G is going to not only become more and more difficult, right, based on a lack of available spectrum or the ease to do that the cost of relocating some incumbent system to do so, you know, might start to eclipse the value of the spectrum itself. And so, you know, this at least to me logically leads to discussions around spectrum sharing, right, and trying to take lessons learned from things like CBRS and move that ball well down the field. And so, you know, Venki, what do you think, you know, the role from your perspective of spectrum sharing is going to be in 6G systems? You may be given some of that context.
Sure. So MITRE senior VP Charles Clancy actually did an analysis recently where he sort of predicted that by 7G, around 93% of sub-6 spectrum would be used by cellular communications. And now, you know, sub-6 is really the beachfront spectrum, right? So that's something that is sought after by everybody. And now we also have this incumbents, legacy incumbents that should not be relocated, that cannot be relocated. So what do you do, right? So you have this tension between these two entities where for commercial, you need more spectrum in the lower band for high reliability communications. And you also have incumbents that are already using it. So the only way to do this, right, the only way to satisfy both of them is to have some sort of a spectrum sharing. Now, we have things like CBRS that we have tried, but there are also bands that are already occupied by legacy systems that require very quick adaptation, right? So adaptation in the order of milliseconds, not minutes or hours. You need to really react to something immediately, and then you need to be able to, you know, shift over to a different spectrum and so on. So to get to that level of adaptation, you also need techniques that are made possible by new open architectures, right? Open RAN and so on. So I think there is a lot of future for spectrum sharing, and that is the only viable way by which we can efficiently use the spectrum. We can satisfy all the requirements of all the incumbents as well as the entrants. So 6G will have, I think, spectrum sharing will have a very significant role in 6G and beyond.
Thank you, Venki. I know I saw a question in the chat, asking, is there something about U.S. spectrum that's better from a 6G perspective than maybe other regions? I don't know that I'd use the word better, but I guess I would just make two observations, and I have a question for Walid about terahertz. One is that, I think it's a true statement to say that the United States has more unlicensed spectrum than I think any other country in the world. And that I think that's a superpower for us when it comes to enabling, the next generation of communications. And despite, LTE unlicensed and 5G unlicensed, I don't think that we've done as good of a job of integrating unlicensed spectrum into, mobile network operations as we probably could. And so I think that to me smells like an opportunity. The other is that, we're already seeing, federal agencies, federal departments, recognizing that there's this gigantic appetite, for spectrum, right, to be made available for commercial uses. And so you see a lot of experimentation, right, being done, in and around the spectrum sharing space. The Department of Defense, right, is doing experiments at Hill Air Force Base, looking at, coexistence between 5G and airborne radar. We have the National Science Foundation, right, John Chapin's program with the National Radio Dynamic Zones. And so, now we have with the CHIPS Plus bill that was recently passed, the funding of NSF Tech Directorate, right, to get after advanced communications. So I think, while that doesn't make our spectrum better, I do think there are some challenges that could be turned into opportunities, right, for industry to take advantage of. But, Walid, certainly one of the hot topics of conversation in my spectrum working group is terahertz, right, is kind of being the last frontier of spectrum that might be easy to use, right? But the easy, right, is because of availability, not necessarily because the spectrum is actually easy to use. And wanted to get your thoughts on what it would look like to try to actually tame terahertz spectrum.
Sure, I think terahertz is a great opportunity for bandwidth and the terabit per second we're talking about. And I think quite a bit of discussions have been focusing on how the physical layer can achieve that, what can we do in beamforming and so on. But I think a more kind of pertinent question that has been somewhat overlooked, and we touched upon it before, is how do we kind of tame the fact that you go to higher frequencies, you have higher rate, but it's more susceptible to blockage and all that, environmental effects. And at the same time, you're saying you want to have that reliably, like for the metaverse. What I mean by reliability here, because there's a question in the chat, is really, can we maintain the quality of service that we want, let's say the rate, in face of possible extreme events, meaning that can it be instantaneously maintained at a certain rate, right? And that's very challenging with terahertz, right? It's very challenging with millimeter wave anyways. So I think that is something we should shed more light on. And one alleviating factor is the terahertz ability to do sensing, because sensing may allow us to have feedback, may allow us to somewhat anticipate what will happen in the environment and then get that reliability that we are missing in some sense.
Thank you for that. Now, Jason, you're in a little bit different of a position, right, with an operator hat on, right, when you look at unlicensed spectrum versus cleared licensed spectrum versus shared licensed spectrum, right? And I think it would be fair to say that just about every commercial operator that I'm aware of has a preference for cleared licensed spectrum, just for the simplicity of actually how you could build out a network, right, on that versus the complexity involved in shared spectrum. Wanted to kind of get your thoughts on what we've been talking about relative to the shared spectrum space.
Yeah, sure. So first, a disclaimer. I'm not making comments on behalf of the entire organization with this response, but I agree that there's definitely a preference for license cleared spectrum, and the reason for that is you can have more planning and more deterministic type of services that can be offered, right? Where you can kind of almost guarantee a quality of service, if you will, but at least a level of service. And you can do math and engineering around that. But when you get variables that are unknown, like happened with shared and an unlicensed spectrum, it becomes more difficult to predict or to offer a consistent type of experience. So one of the things that I'm personally, my personal opinion, a fan of is actually supplementing licensed with the shared or semi-licensed in a supplemental way. That way you can still have kind of the best of both, right? You can take advantage of the consistent experiences that can be available for the cleared license spectrum, and you can kind of have a minimum level of service, but in certain locations and situations and whatnot, you could actually kind of supercharge that, right, to supplement and enhance that with additional spectrum that might be available, and offer that. So I do think that there's a lot of potential there, and the higher the spectrum, the harder it is to deploy, right? And we talked about getting it in the building earlier, but some of the economics on how you do that, right, for traditional network builds, for leasing and power and all those kind of things, the construction that go into these sites, it's going to make it really difficult. But if there was a shared component for some of these, it makes it a lot easier. And so I do think that there's potential for that, and especially in a supplemental kind of way.
Thank you for that, Jason. Now, Prasanth, you just heard, right, everybody's dream, right, around what would have to occur, right, to kind of enable 6G from a spectrum perspective, right? Jason, I like the idea of, that obviously, operators, will maintain their spectrum assets that they currently own, but then bonding, if you will, a shared license capability on top of that, and then take it further and say, and also you're going to fully take advantage of all the unlicensed spectrum. Prasanth, you guys are going to have to build this. What do you think?
Yeah, I think certainly we want to do that. So from the network gear point of view, we already support various kinds of spectrum. The exactly which spectrum is available and who owns that, we don't have that under our control. But certainly making radios that support different bands, that's in our control, and we do our best to support all the different bands here.
Yeah, I guess the one thing that I would point out, and I think it was also recognized in the chat, is that when you look inside organizations like 3GPP, there's not a distinct focus on the concept of sharing spectrum, right? Certainly, we've seen trying to take advantage of unlicensed spectrum with Wi-Fi offload and things like that, but the design is around the presumption of cleared licensed spectrum. Do you think there's runway inside organizations like 3GPP to create the standards that would further enable the vision I think Jason just laid out for us?
I cannot answer from the standards perspective, but certainly from products perspective, today I can tell you that we have products which support CBRS, which support unlicensed LTE and multi-fire. These are all different unlicensed band products, and going forward, I'm sure that we'll continue to support these. Personally, I don't have enough expertise here to comment on the standards point of view.
Yeah, fair enough. I just, it's one of those things where, the complexity, right, that Venki was talking about earlier, right, of trying to accomplish, simultaneous transmission on cleared licensed, shared licensed, and unlicensed spectrum to enable you to have enough bandwidth to drive the applications and use cases we've been talking about. That's easier maybe from a base station perspective, might be much more difficult from an end user device perspective. And I think we heard,
definitely,
right, in the last panel, a device ecosystem issue around the lack of millimeter wave end user devices.
Yeah, and right. I can affirm that already from looking at our test bed now. So for one of our test beds, we are considering a millimeter wave and low band non-standalone network, and finding devices for that has proven extremely hard. So yes.
So we have our work cut out for us, right? But I think, you know, we've laid out a number of things that I think will, you know, maybe be the rubric by which we can try to get after, you know, what 6G is going to need from an enabling perspective, a technology perspective, you know, that would get us beyond what 5G, or at least the promise of 5G is today. And, you know, looking at the fact that 6G is probably going to have to pick up some pieces for what 5G didn't quite accomplish, right? You know, looking at some of those use cases that Jason brought up around the URLLC space, right? Massive machine type communications. I think, you know, we didn't really get into that too much, but I certainly think, you know, that may, you know, find its way into being more fully enabled in 6G as well. So appreciate everybody's time today. I think we're at time for our panel. So I think we did pretty well having a good conversation around 6G. Hope the audience enjoyed that and tried to get to as many of those questions as we could. So I think it's back over to Ajit and Layla.